Welcome back again to WSHS Algebra 1 Virtual Tutor. What we're going to do today is continue with factoring. So last you learned about GCF, greatest common factor. And that's going to tie into what we're doing today, which is factoring completely second degree polynomials. So whenever you see this word factor, the first thing that should pop into your mind is there a greatest common factor? Okay, so when we're doing these, we're always going to look for a greatest common factor first. But afterwards, we're going to also start to notice that there's different patterns of these polynomials, and we have to try to recognize when they look a certain way, then we're going to be factoring them a certain way. So the first thing we're going to talk about is some basics here. So the standard form of a quadratic. So when I was talking about that pattern, what I meant was when the polynomial looks something like this, where we have an x squared in the front, some term with an x in the middle, and then a constant, meaning a number by itself at the end. So if you see something like this where there's three terms, which means trinomial, remember that. So we have a trinomial and it kind of looks set up this way. Okay, so what I want to do is talk about what these mean, what each term actually is called here. So this first term, I mean, we usually call it the first term, but there's a more defined vocabulary term for this. This is also known as a quadratic. Okay, so we know it's a quadratic because we see that it has a squared term here. So squared has, a square has four sides, right? So Latin quad, meaning four. So even though that's not an exponent of 4, technically it comes from the term squared. So the first term here is a quadratic. You might hear it more known as first term. The second term here in the middle is known as the linear term. And this is a linear term because it only has this one single variable here. There's no exponent greater than that. So that's known as a linear term, but we usually call it the middle term. And then the last part of this trinomial here would be known as the constant. And the constant is when you have a number that has no variable attached to it. It's probably the easiest definition for that. So the constant is also known as the last term of the trinomial. Okay, so we're going to just practice identifying each part of this trinomial. So number one has 2x squared plus 3x minus 5. So the first part is the a, or the quadratic term. The quadratic term is the one with the x squared, so we're looking at this one here, and we're just identifying the number that's in front of this, so the coefficient of this quadratic term, and the coefficient is just the 2. The linear term, or the middle, or the b, is the coefficient of 3. And then the c, or my constant, is the last term here, but we've got to be careful because we have to always take that sign that's in front. So the constant is actually negative 5. Okay, for number 2 here, my quadratic term, or my first term, my a here, there is no coefficient there. So typically we're used to seeing a coefficient, but if there's not, then technically there's that invisible 1 that likes to pop up. Okay, so my quadratic term would be 1. My middle term, or my linear term, would be negative 6, because we always have to take that sign in front. And then my constant would be negative 16. For number 3, this is not a trinomial, this is a binomial. There's only 2 terms here. So how would we do this one? Well, I see the quadratic term, meaning the one with the squared, is always my first term, or my a term. So again, there's no number in front, so we would have that invisible 1 there, so we can say the quadratic term is a. The linear term, the b, the middle, is the one that has that single x. Remember that? So if we look up here, it has to have a single x. Well, in this one, we don't have a single x. There is not one. So technically, the middle term would be 0. There isn't one there. And then the constant is, remember, constant is the one without a variable. So this negative 49 does not have a variable. So that's technically the C, or the last term. So when we are factoring trinomials or binomials in this case that look like this, they have the x squared or the a squared or whatever variable it is, but more importantly they have the squared term. They have some sort of middle term, or the middle term is missing, and they have a constant at the end, the last term. When we see these types, we're going to factor them a specific way, and that's what you're learning today. Okay, so when we're doing that, we're kind of looking for what I like to call a magic pair. So we're looking for a magic pair that would multiply to a certain number and add to a certain number. And typically we find those numbers in the trinomials. So this part here of the notes is just kind of practicing how to problem solve. So what numbers multiply and add to the given numbers in the table? If I want to do this one here first, I'm looking for numbers that will multiply to 24 and add to 10. So first, I'm looking at 24. What numbers would multiply to give me 24? Well, we've got 1 times 24. We've got 2 times 12, 3 times 8, 4 times 6. But which one of these pairs here, the magic pair, would also add to give me 10? So if I added 1 and 24, 1 plus 24 actually gives me 25, right? So this is a no-go. 2 plus 12 would give me 14, so that's a no-go. 3 plus 8 would give me 11. That's not going to work, but we're getting closer. 4 and 6. If I added 4 and 6, I do get 10. So this is my magic pair here, more importantly, the 4 and 6. 4 and 6 would be that magic pair. Let's try this middle one here. I need numbers that multiply to negative 12 and add to negative 4. Well, when they're negative, when you multiply a positive times a negative, that will give you a negative. So this means if my number's negative, I need one to be positive and one to be negative. So 12 would be 1 times negative 12, right? 2 times negative 6, 3 times negative 4. And we could actually switch the negative sign around too, but let's test these out and see which ones would give me negative 4 if I added them. So if I have 1 plus negative 12, that's actually going to give me a negative 11, so that's not going to work. If I have 2 plus negative 6, that's going to give me negative 4. And that's actually what I'm looking for, right? I wanted it to add to negative 4. So here's my magic pair right here, a positive 2 and a negative 6. And then finally, we want it to multiply to a positive 36 and add to a negative 13. Well, let's try and see what we got. 36 is 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So which one of these will give me a negative 13? Well, if I have positive numbers, positive plus a positive is a positive. So how would I get a negative here? Well, let's just see what we have. 1 and 36, that's going to give me 37. There's no way that's going to be close enough. No way this is going to work. 3 and 12 is 15. I'm getting a little bit closer. 4 and 9 is 13. 6 and 6 is 12. Well, 13 is pretty close, or almost looks, not close technically, but almost looks like a negative 13, right? 13, 13 are almost the same. So positive 4 and positive 9 will give me a positive 13. If I made the 4 and the 9 both negative, then if I added negative 4 plus negative 9, that would give me a negative 13. So that works. But does a negative 4 times a negative 9 also give me a positive 36? You see, it has to work all the way or it's not going to be your magic pair at all. So can you do negative 4 times negative 9 and get a positive 36? Of course, negative times negative is a positive. So this works. Negative 4 and negative 9 is going to be my magic pair. So these take a little problem solving. It takes some thinking. Sometimes we're going to see the magic pair right away, Other times you have to kind of work it out and take a few minutes to actually try and get it, but you will. All right, so the next thing I want to do is talk about how we get these factors. Okay, so when we're factoring trinomials and quadratics like this, we're actually doing the opposite of multiplying. You learned multiplying binomials before, so factoring is actually doing the opposite of that. So if I had these binomials, x plus 3 times x plus 8, if I multiply them, I would actually get x squared plus 11x plus 24. And I'll do that quick check just to make sure you remember what I'm talking about here. Remember when we multiplied a binomial times binomial, we usually did the box method. So we have x plus 3 and x plus 8. And then we said this would be x squared 8x, 3x, and 24. And then we talked about noticing that these diagonals here are typically like terms, so we're going to add them together, which will make the final answer x squared plus 11x plus 24. So that's where this came from. That's what I'm talking about here. If I multiplied those, I would get x squared plus 11x plus 24. So if you notice here, the last term, the 24, is actually the product, meaning we actually multiplied the 3 times the 8, right? And then the middle term, the 11, is actually the sum. So we went ahead and added the 3 plus 8. So factoring binomials, or factoring trinomials, I should say here, is like doing the opposite of multiplying binomials. So what we're going to do is factor, and then our answers are going to look like this, where we'll have two sets of parentheses with some x's split up, some numbers there, and some signs, okay? So quick recap, when finding factors in the calculator, you would press the y equals button, whatever number you're looking for divided by x, and then you want to press second graph to get to your table to see all the factors if you're having trouble finding it right away. All right, let's get into the actual factoring part now that we have the basics set. So first example, x squared plus 15x plus 54. How do we do this? Well, the first thing I want to know is if it said factor, I want to always check for a GCF. So between the first term, middle term, and last term, between the 1, 15, and 54, do I have a greatest common factor? And I don't, because there isn't anything other than 1 that they can all be divided by. They don't all have a variable either. So if there is no GCF, and I see a pattern like this where I have the x squared first, the x in the middle, and the constant at the end, then I'm going to set my factoring and I'm going to try to work it out like this with the magic pairs. Okay, so I'm looking for numbers that will multiply to something and add to something. So how do I know which ones to do? Well, factoring is working backwards, so we're going to look at this backwards. Okay, so we want to find numbers that multiply to 54 and add to 15, that magic pair there. So 54. Well, 54 would be 1 times 54, 2 times 27, but more importantly, we have 6 times 9. And 6 times 9 would also give me 15 if I added them, right? So 6 and 9 are going to be my magic pair here. And they are both positive numbers, positive 6, positive 9. So the way I'm going to write my answer is I'm going to create two sets of parentheses. Okay, my x squared is getting split up in the front end of these parentheses. So that would be x and x, right? Because x times x is x squared. So working backwards, I'm splitting the x squared up into two factors, x and x. And then my magic pair here, they were both positive. So I'm going to put my magic pair in the parentheses. So I have positive 6 and I have positive 9. Okay, and if you notice, the last term, the constant here, if I split the 54 up, that is 6 and 9, right? 54 is 6 times 9. And then I want to check, is 6 plus 9 15? And yes, it is. That does work. So my answer will be written this way, x plus 6 and x plus 9, and I'm putting them in parentheses here. Okay, example 2. So I'm going to be factoring this again, and I see 2x squared plus 12x plus 18. So if the directions say factor the following or write the factored form of the following polynomial or the given trinomial, then again, that word factor means I'm always going to be looking for a GCF first. Do they have a greatest common factor that can come out? And if you look here, between the 2, the 12, and the 18, they do have a GCF. And the GCF would be 2, because 2 can be divided by all of them, right? 2 can come out. So I can actually remove the 2. So remember, when we removed the GCF, we still had to write what was left over in parentheses. And we did that by taking the original and dividing it by whatever the GCF was. So 2x squared divided by 2, well, 2 divided by 2 is 1, so I'm just going to be left with 1x squared. And we typically don't see the 1 in front, so I'm just going to write x squared like that. Then 12 divided by 2 is 6, so this becomes 6x. And then 18 divided by 2 is 9. So now I've changed that trinomial. I've kind of rewritten it to look like this. 2 parentheses x squared plus 6x plus 9. So you're not finished unless there's nothing else you can do to factor this, okay? So if I notice what was left over in parentheses is set up like that trinomial that we've been looking at, right? Where we have a quadratic, a square term in the front, a linear term or the single x in the middle, and the constant at the end. So if we see this special pattern, then we want to check for a magic pair, okay? So we want to see, and with the magic pairs, we're working backwards. Do I have any numbers that would multiply to give me 9 and add to give me 6? So that's what I'm setting up in my table here. Multiply to 9 and add to 6. Well, 9 is 1 and 9, right? Or 3 times 3. If I were going to add 1 and 9, that's going to give me a 10, so this is not going to work. If I add 3 and 3, that is going to give me a 6, right? So 3 and 3 is my magic pair, and they're actually going to both be positive. Positive 3 times positive 3 is positive 9, and positive 3 plus positive 3 is positive 6. So I can take this inside part, this trinomial, and I can actually factor that by itself. So this would be, remember, the x gets split, right? X squared gets split, x and x. And then the 9 got split, or that magic pair got split into positive 3 and positive 3. So if we look, the 9, right, split to 3 and 3, and then 3 plus 3 is also 6, so this works. So what happens to my GCF, though? Remember, I took that 2 out first? Well, the 2 has to stay there. We can't just make it disappear, so we just bring it down in front. Okay, so my final answer here would be 2 parentheses x plus 3 parentheses x plus 3. Okay, now we're going to, this says factoring when a is greater than 1. Remember, the a was the quadratic term, which was the one that was written first, the one with the x squared. So when the a is greater than 1, we have to kind of do a different step here. So what we notice first, though, it says factor, right? So we want to find a GCF. Is there a GCF that can come out between the 2, what number would this be? If there's nothing there, it would be a 1, but because it's a negative, there's a negative 1. So between 2, negative 1, and negative 3. There is no GCF. There is no number that can be divided by all of them, or no highest number other than 1, so that wouldn't make a difference there. So there is no GCF here. But I still see, it almost looks like that pattern that I've been getting used to, right? Where I have an x squared first, an x in the middle, and then a constant at the end. So now I want to say, okay, well, can I do a magic pair at all? But when I did the magic pairs, usually there was no number in front of my x squared, right? So whenever we see that there is a number in front, like it would be greater than 1, right? So like 2, or if I saw a 3 in front here, or 5, or anything that's greater than, any number in front of the x squared, anything greater than 1. I'm going to do something called slide, divide, bottoms up. Okay, so what I mean by slide, divide, bottoms up is first we're going to take this term here, this first term 2, this coefficient, and we're going to slide it over back to the end, to the constant, because I want to rewrite this so that I see just an x squared in front, and then I can find my magic pair easier. So when I slide this 2 over here, what I'm doing with the slide is I'm multiplying. So 2 times negative 3, right? This is a negative 3 here. 2 times negative 3 is negative 6. So I'm going to take this and I'm going to rewrite my trinomial here. Because I slid the 2 over, I removed it. So it's no longer in front of the x squared. So I can rewrite this as x squared minus 1x. And then I rewrote the last one as the negative 6. Because when I slid the 2 over, I changed this negative 3 and I turned it into a negative 6. Now, if you look at this, I kind of have it set up nicely to where I can see a magic pair, okay? So if there's no number in front of the x squared, then we're looking for a magic pair that would multiply to give me negative 6, multiply to negative 6, and it's got to add to give me a negative 1. So let's find some factors here, some numbers here that would multiply to negative 6. Well, you have negative 1 times 6, negative 2 times 3, but at the same time I can also switch the signs here. I could also have a positive 1 times negative 6, and I can have a positive 2 times negative 3. All of these combinations would give me a negative 6 if I multiplied them. But if I added them, what would they give me? So if I added negative 1 and 6, that's going to give me a positive 5. If I added negative 2 and a positive 3, that's going to give me a positive 1. If I added a positive 1 and a negative 6, that's going to give me a negative 5. And then a positive 2 and a negative 3 is going to give me a negative 1. So again, which one adds up to that middle term? Remember, I needed a negative 1. And I found that this combination here, this magic pair, is going to work. So this is a positive 2 and a negative 3. So I'm going to write my factors. Again, I'm going to split the x squared up in the front into x and x. And then I put my magic pairs in here. So I had a positive 2 and I had a negative 3. And that actually comes from splitting up the negative 6, right? And then we're always checking to make sure we did get it to add to that middle term there. All right, so at this point, you're used to this being your final answer, right? But we have to take it one step further. When we saw that there was that 2 in front, we did the slide, and we multiplied, and we rewrote, and found that magic pair, right? But this is called slide, divide, bottoms up. So we did the slide part. Now we have to do the divide part. Now, the reason why we have to do the divide is because when I did the slide, I multiplied, right? And math is all about a balancing act. So what you do to one, you must do to the other. So if I slid the 2 over and I multiplied it, then I have to kind of undo what I just did. I have to bring it back mathematically. I have to balance it out. So when I slide, I must also divide. So at this, and slide and divide sort of rhyme, right? So you want to keep that in mind. So at this point, we're going to divide the numeric portion by whatever number we just slid over. So I slid the 2, that means I'm going to have to divide the 2. Okay? So when I do that, 2 divided by 2 is 1. So this factor now becomes x plus 1. And then negative 3 divided by 2, well, that's going to give me a negative 1.5. So if you're checking that in your calculator, you get a decimal. You cannot leave your answer as a decimal. So I did the slide, I did the divide. This bottoms up portion, that comes from this situation right here. When we have a situation where we're trying to divide but we get a decimal and it doesn't work, that means we take this bottom and we bring it up to the top, up in front of this x. So that's where the term bottoms up comes from. So I'm going to rewrite this factor as 2x minus 3. Now this takes some practice and getting used to, but once you've done it a couple times, it starts to stick with you and you can get it done a lot faster. So I'm going to do a couple more of those in a little bit. All right, example 4 is going to be similar to this. Okay, so I have 2x squared minus 9x plus 9, and I have to factor this. So first thing I want to check for is a GCF. Do I have a number that can come out of 2, 9, and 9, or do I have a common variable that can come out? All three of them don't have a variable, so I can't remove any type of GCF here. There is no GCF. So then I say, okay, well, can I do the magic pair? Well, my first term has a number in front, so I can't do this magic pair yet. What I have to do is get rid of this number in order to do the magic pair. Okay, so to get rid of it, I'm going to do the slide divide bottoms up. So I take the 2 and I slide it over to the 9. When I slide, I'm multiplying. So 2 times 9 is 18. So by sliding the 2 over to the end, I no longer have it in front. So I can rewrite this as x squared minus 9x, so the middle also always stays the same. And now the last term, because I slid it over to the 9, I've combined it. I multiplied it and I made it 18. So that becomes my new last term here, 18. Now this trinomial looks pretty good. It looks like I can get a magic pair out of this because I have an x squared in the front, x term in the middle, constant at the end. So that should ring a bell for what's the magic pair here, okay? So I need numbers that are going to, and remember we always work backwards, what numbers multiply to give me 18 and add to give me a negative 9? Okay, so we have multiply to 18 would be 1 times 18, 2 times 9, 3 times 6. And that's about it, right? If I added 1 and 18, that's going to give me a 19. If I added 2 and 9, that gives me 11. If I added 3 and 6, that gives me 9. So I'm pretty close, but my 9 was supposed to be negative, not positive. So in that case, I can say, okay, in order for me to get a negative 9, then that means both of these are going to have to be negative, because negative 3 plus negative 6 gives me negative 9, and negative 3 times negative 6 does give me a positive 18. So there's my magic pair right here. So I'm going to write my factors. Once I find the magic pair, the x squared gets split in the front, x and x, and I write the magic pairs inside. So I had a negative 3 and I had a negative 6. So you keep the signs there. So again, it looks like I'm done, but I'm not quite, right? Because I did the slide, I must now divide. They go hand in hand. Slide, divide. Okay, so what number am I dividing now? Well, I'm going to divide the number that slid, right? The number that I just slid over. So if I slide 2, I must divide 2. And it's not always going to be 2. It's just whatever number was in front, right? It just happened to work out that it was 2 for both of our problems here. Okay, so now I have negative 3 divided by 2. So again, if I try to do the division and I get a decimal, that's where the bottoms up comes from. So I'm going to take this 2 from the bottom and I'm going to bring it up in front of the x. So this factor actually becomes 2x minus 3. And then the second factor, can I do negative 6 divided by 2? Well, yeah. Negative 6 divided by 2 is negative 3. So now I'm finished. So whenever you slide, you must also divide as your last step. Bottoms up comes when you have a decimal after you've done the division. You just bring the bottom or the denominator up in front of the x. Okay, example 4, last one here. So actually that should have been example 5, right? So I have 2x squared plus 12xy plus 16y squared. This time I have more than one variable. That doesn't necessarily make it any more difficult here. I'm still going to, because it said factor, I'm going to look for a GCF. So do I have a greatest common factor between the numbers and the variables here? Well, I see that this is a 2, a 12, and a 16. So I can actually remove a 2 from here because the 2 can be divided by, or we can divide the 2 by all of these terms here. All the terms can be divided by 2. Sorry. All right, so I can remove a 2, and then there's more than one variable here, but can I take out a variable? I can't because they don't all have the same one. They don't all have an x, and they don't all have a y, so neither one of them can come out. So the GCF here is just a 2. So I have to go in and I have to divide each one by 2 to figure out what I have left over here. Oops. Divide by 2, divide by 2, divide by 2. So what would be left in parentheses? We would have 2 divided by 2, it's 1. So I have an 1x squared left over. 12 divided by 2 is 6, so this becomes 6xy. And 16 divided by 2 is 8, so that becomes 8y squared. So now I want to check here, do I have a magic pair situation? Well, I have the first term as a squared, the middle term has the x, or the variables with the exponents of 1, and then the last term has a y squared. It's not a constant, it's a y squared. So what do I do with that? Well, this technically is the same. We can do a magic pair here. So remember before when we said that the x squared in the front gets split into x and x, right? Well, because we have a y squared at the end, this y squared would actually get split up at the end into y and y. So that's okay. It's okay to have a second variable at the end. So what I'm doing now is, do I have any numbers that multiply to give me 8 and add to give me 6? So we have to multiply to 8, add to 6. And I do. If I did 2 times 4, right? 2 times 4 is 8, and 2 plus 4 is 6. So the 2 and the 4 would work out, and they would both be positive. So the way I would factor this one is the 2 and the 4 just get written here. So this becomes x plus 2y and x plus 4y. So if there is a variable at the end, like this y squared was, it doesn't make it any different. That just gets split up at the end. So we still factor the same way. And we can't forget about this GCF of 2. We have to still bring it down. So my answer here would be 2 parentheses x plus 2y, x plus 4y. And that is it for factoring.